Everything you see here is real data. We're looking through a microscope at neural tissue, going down through an area of the brain called the medial prefrontal cortex. We can use these microscopic images to reconstruct the three-dimensional layout of the neurons and really see the intricate and intertwining patterns that they make. These connectivity patterns throughout the brain underlie all neural function and are responsible for everything from controlling your muscles when you tie your shoes to how you feel about your family. Understanding these patterns is a massive ongoing project for neuroscientists everywhere and could lead to breakthroughs for everything from consciousness to depressive disorders and schizophrenia. In this example, we injected purple dye into a far distant brain region called the amygdala, which is largely where our emotions and feelings of fear are generated. The purple wires are axons, or connections, coming from the amygdala into this area. We've also used some recent advancements in genetic engineering to select only the neurons inside this region that connect to the amygdala and dye them green. By combining both the green and purple dyes, we're able to see the full circuit of connections, viewing both the neurons that connect to the amygdala and connections coming back in from the amygdala. The locations and patterns of the neural connections, called synapses, show us how heavily these two groups of neurons are connected. To help us start to understand the incredible complexity of these neural networks, we develop computational techniques that segment or isolate individual neurons. By isolating a neuron, we can measure its characteristics, like size, shape, how many branches it has, and what general type of neuron it is. This may not seem like much, but it's really important for understanding so much about the brain. For instance, we know that malnutrition, stress, and cognitive disorders can all change how these branches look, but there are so many details that we don't know. That's why we, as scientists, keep pushing the envelope. To tackle these very complicated questions, we are getting together and combining fields ranging from physics and biology to mathematics and computer science. Every year, every day, we learn so much more. This is the most exciting and progressive time for neuroscience that there has ever been.